Okay, so here I've got a T cross section. It's held together with nails along the length of the beam here. So I know that this is seeing a shear force of 1600 newtons. I know each nail can hold 750 newtons in shear. Again, these nails are along the length of the beam. And I want to figure out basically how close do I put the nails so that this thing holds together. So I'm going to use shear flow again, Q, which is equivalent to the force per length, right? So we're going to use that. That's the length between each nail that we're going to use here. And that's going to equal VQ over I. So the first thing I need to do is find the neutral axis, right? Y bar, so I can base everything off of that, find the moment of inertia, all that good stuff. So so I got two things here, two rectangles here. The first one's at 0.1 times 0.05 times 0.2, and then I've got the top one, which is going to be 225 is the location of that one, and it is 0.2 times 0.05 divided by the total area, which is 0.05 times 0.2 plus 0.05 times 0.2, and I find that the neutral axis is located at 162.5 millimeters, or 0.1625 meters. Okay, so now that I got that, now I can go ahead and figure out what Q is. Okay, because again, Q is going to be y bar prime over a bar, or not a bar, a prime, I should say. Okay, and again, what I'm going to look at is just this top rectangle, because that's the interface between the two boards. That's where the nail is going to shear, is right at this point right here at that interface, right? So I'm going to, draw my cut there essentially and look at the area above that, okay? So the location of the center of that guy is again 225, but from the neutral axis, so I gotta subtract off the 162.5, like so, and then times that area, which is going to be 0.2 times 0.05, okay, and that gives me a Q of 625 times 10 to the minus 6, and again, that'll be meters cubed on that guy. Okay, so next thing I need to do is find the moment of inertia I. Okay, again, from the neutral axis, or about the neutral axis. So I will start with the bottom one, 112 BH cubed, where B is 0.05, H is 0.2 cubed, right? Plus the area, which is 0.05, 0.2, and then the location of that centroid is at 100, so it's going to be 0.1625 minus 100 squared. Okay, now we do the top one, add it to it, so that has a base of 0.2 and a height of 0.05, okay, times its area, same area, 50 times 200, and then its location of the centroid for the parallel axis theorem is given by that. So I then becomes, adding those together, I get 114 times 10 to the minus 6 meters to the fourth. All right, so now I got Q. Basically, I have everything I need. So again, the shear flow is the force per length, right? So basically, I know that each nail can hold 750 newtons, okay? I want to figure out how far to space those. So my shear flow is going to be 750 divided by S. S is what I'm looking for. And then that's going to equal VQ over I, where V is 1600 given in the problem statement. Q is 625 times 10 to the negative 6. And then I is 114 times 10 to the negative 6. So, solving for that, I can find that the spacing of the nails has to be every 8.52 centimeters. Okay, because again, basically what that's saying is the shear flow is basically 750 newtons per 8.52 centimeters. Okay, so if I do it any more than that, then the shear will be too great on those nails. They won't be able to hold them. So I have to put them, at that distance to, set that shear flow that is created by the 1600 Newton shear on the beam.